Two people can take the exact same probiotic, yet one sees a significant health improvement, while another experiences no change at all. Your gut microbiome functions as a sprawling regional rail network. When you swallow a probiotic, you are launching a new fleet of trains, attempting to establish a regular daily service on existing tracks. If the environment is calibrated for these new arrivals, the trains seamlessly merge into the traffic flow. This successful docking is known as responder biology, a state where the new microbes achieve colonization and provide ongoing health benefits. But if the environment is hostile or overcrowded with native bacteria, the new fleet cannot find an open station. They simply pass through the digestive tract and exit the body, a failure called non-responder biology. A probiotic's value depends on whether it can avoid this route mismatch and align with the host's biological architecture. Every introduced microbe must obey two ecological rules to survive. First, there must be empty physical space or uneaten food resources available within the gastrointestinal tract. This niche difference means if native microbes occupy the receptor slots, new probiotics cannot find a platform. Survival then depends on relative fitness difference. A probiotic with higher metabolic fitness outcompetes native microbes to claim a slot. Mapping these ecological mechanisms turns probiotic therapy into a predictable calculation of network compatibility. Geography shapes your microbial transit system. Decades of localized eating habits force your digestive bacteria to evolve specialized tools to process your specific diet. The Indian gut microbiome is highly distinct, characterized by a 39% concentration of a bacteria called Prevotella capri. This bacterial dominance is driven by the traditional Indian diet, which relies heavily on plant-based, complex carbohydrates and resistant starches. To survive this intake, the native gut bacteria evolved cazymes, carbohydrate-active enzymes, to break down these tough plant materials. These specialized enzymes function as massive unloading cranes, built specifically to tear apart rigid cargo like xylan plant fibers. Generic Western probiotics often fail here because they lack the biological equipment required to unpack this regional cargo, leading to a complete system failure. Subjecting this specialized regional infrastructure to a radically different environment can lead to biological collapse. When Indian populations migrate and abandon their traditional eating habits, they undergo dietary acculturation, a profound biological shock. This transition involves a diet of ultra-processed foods, high fats, and low fiber intake. Without the complex plant materials they were built to process, the Prevotella capri colonies decline, leading to a generational loss of vital cazymes. This rapid loss of protective bacteria is directly linked to the rise in chronic inflammatory conditions like inflammatory bowel disease. Both westernized diets and generic probiotics often ignore the host's native regional programming, causing the internal transit network to fail. Precision science offers an alternative, identifying the exact bacterial strains a local population is missing to deliver targeted replacements. This requires high-resolution data. Researchers analyzed 40,000 microbiome samples to map the biological deficiencies specific to the Indian population. Rychbiome Indus utilizes this data for route-specific scheduling, deploying 7 clinically identified microbial strains that are frequently depleted in the Indian gut. It delivers these missing strains at a potency of 50 billion colony-forming units, ensuring a high volume of live microbes survives the stomach's acidic environment. To ensure they have the energy to dock, the formulation is a synbiotic, combining live strains with FOS prebiotics, non-digestible fibers that act as fuel tankers attached to the incoming fleets. By sending the precise missing trains equipped with their own fuel, scientists can guarantee successful route integration, regardless of local station conditions. Once colonized, these fleets began manufacturing short-chain fatty acids, delivering pure energy to the cells lining the colon. This energy fuels the production of tight junction proteins, the biological glue that seals the microscopic gaps between intestinal cells. These reinforced walls separate the gut contents from the bloodstream, blocking toxins and undigested food from leaking into the body and causing inflammation. These microbes also interact with your immune cells to stimulate regulatory T cells, the peacekeepers that stop your immune system from attacking your own healthy tissues. Mapping your internal transit system with diagnostic tools allows precision formulations to target the exact points of failure and restore the gut's natural function.